Cross-validation in machine learning. My name is Richard Kirschner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. What is in it for you? We're going to cover the need for cross-validation, what is cross-validation, steps in cross-validation, and types of cross-validation. And then of course we'll do a nice hands-on demo so you can see what it looks like in Python code. Let's start by exploring the need for cross-validation. While choosing machine learning models, we need to compare models to see how different models perform on our data set. This goes beyond just comparing different models, but also in explaining this to the shareholders or whoever you're working with. You really need to know how valid is your data set or your models that you're working with on the data set. So the need for cross-validation comes up when the data is usually limited, and training and testing on the same portion of data does not give us an accurate view of how our model performs. And this just makes sense. If I'm going to program a model to outguess something, I don't want to use the same data I trained it with. I want to see how it performs on the next data. Otherwise, I'm just kind of like giving myself my own juice, saying, hey, my model did really good because this is what it's based on. Self-fulfilling prophecy. And that is still important to do because you still need to run it on your own data to see how well your set fits your data versus how well it fits new data coming in. So training a model on the same data means that the model will eventually learn well for only that data and fail on new data. This is called overfitting. So you might write a wonderful script. It works great for predicting the failure on loans for a bank, but it only works for the data you already have, not the new data coming in. And that, again, is overfitting, so it's not going to give you you're not going to get a good value as to how good your model is going to fit the new data coming in. So what is cross-validation? Cross-validation is a technique which is used to train and evaluate our model on a portion of our database before reportioning our data set and eventually using it on the new portions. Consider the block shown to be our complete data set. And you can see we've already taken the data set and divided it into 4 sections. And here we've cut out one section highlighted in yellow. We partition the data set into training and testing data. And you'll see that in this particular example we've taken 75% of the data, or 3/4 of it. And we said, okay, we're going to use that to train our model. And the testing data set will be used by our model to predict on unseen data. It is used to evaluate our model's performance. And this is what we were talking about, is you want to be able to train it on one set of data, come back and say, hey, this is how well it performs on data it's never seen before. Now, there's an interesting relationship between these, and it's important to also see how well it performs on the trained data. We're not going to talk about too much on that one. It's usually used in higher end neural networks, and it's one of the ways they know when the training data is done and the testing data and the predictions kind of match. That's when they start looking at, okay, you've trained it enough. And you can see here, we take the first partition and we go ahead and we map how good it did. And we partition the data set into training and testing data. We then choose a different portion of the data for training and testing and reevaluate the model performance to get more accurate results. And you can see here we've colored it in a nice pretty yellow for you. And so we've tested on the first section and now we're testing it on the second section. So we're still using 3/4 of the data to train our model and 1/4 to test it. And we just loop through all the different quarters to test it. That's what we're talking about when we talk about cross-validation, is we want to be able to get a picture of how it works on the data it hasn't seen. And we look at the steps in cross-validation. The steps involved in cross-validation begin with step 1, split the data into train and test sets and evaluate model's performance. And so we measure 1, we measure 2, we measure 3, and we measure 4. And each one of these generates its own performance rate based on the other 75% being used to validate that data. How well does it perform on the unseen data? And so we have actually created 4 separate models. And then we just take those measurements, 1, 2, 3, 4, we add them together, divide by 4, or however many divisions you use, and you get a total model performance. For myself, when I first start doing a new data set, I'll start with just partitioning it into 3, because it runs faster, it's quick. You only have to run 3 models, that kind of setup. A lot of this depends on how much data you have. If you have a lot of data, 3 works just fine. If you're very limited on how much data is coming in, you might want to divide it into more validation sets when you're first testing out your models and your data sets. And there's other steps in here we'll look at in just a moment. Types of cross-validation. Now this is important because we looked at one type. This actually we're going to put down as the number 2 type. One of the ways we can do this is what they call leave one out cross-validation. This is where the entire data set is used for training and one singular data point is kept as the testing data. Consider a data set with n points. N minus 1 will be training set and 1 point will be testing set. Leave one out cross-validation is then we go to another point and it'll be chosen as the testing data and the rest of the points will be the training. This will repeat for the rest of the data set n times. And yes, we're creating, if your data is n, well, they used n minus 1 n, so we'll do it n minus 1 times, and you create n minus 1 models that you're testing across your data set to see how good your model does. The final performance measure will be the average of the measures for all n iterations. And so you add up all those different measures and divide by n minus 1. Now keep in mind, at the end, you just run it across all the data and that's your final model that you're going to actually push out. This is to validate it. This gives it an n minus 1 validation. You can imagine if you're dealing with big data and you have terabytes of data, doing it this way would probably be a very bad idea. You might have to wait a month before you get an answer. Where dividing it into smaller portion works. So again, we're dealing with smaller amounts of data usually when you do this level of cross-validation. K-fold cross-validation. This is what our example initially was, and this is what most people look at is you divide it into, in this case, 4 sections. So the data is divided into K number of different sections. And like I said, I like to use 3 if I'm just initially looking at the data. It gives a decent training model versus a faster run, so at least I know I'm using 66.66% of the data. One section is for testing and the rest for training. The number of sections, K, is selected depending on size of data set. Again, if you have a very small data set, you want your K to be much larger because you really can't divide out most of your data. You lose so much in the training. And so if you divide it out enough, you end up with leave one out cross-validation. We divide it all the way to each data point gets its own run. And this will generate, if we do K equals 5, it will generate 5 different models for you to evaluate on. And so of course we're generating each one. The final performance measure will be the average of the output measures of the K iterations. So we add them all together and we divide by K. So we're going to have 5 models, there's going to be 5 measurements, and we'll divide that by 5, and that gives us a good guess, good estimate of what the measure is on this particular cross-validation going on and how good our model is. And then you train the model with all the data in the end because you don't want to leave one section out. Now, one of the things, and I'm going to point that out on this page before we get into the next validation, what happens if your measurements are all over the board? You've divided into 5 sections. One measurement is really bad, one is really good. That means there's something going on with the way you divided your data and how the data is set up. And we want to start looking at stratified K-fold cross-validation. The data is split so that each portion has the same percentage of all the different classes that exist in the data set. Consider a data set which has 2 classes of data as shown. In normal cross-validation, the data is divided without keeping in mind the distribution of individual classes. The model thus cannot properly predict for minority classes. And you could think of this in that if you were, let's say, you had data set that was looking at drivers. How good do drivers do when driving their car? And one of the features is the color of the car. Now, my guess, it probably wouldn't have a huge impact as far as the data, But let's face it, there's the most common car out there is probably white, there's probably brown, and you get into like fire engine red. It only has a few red cars. At that point, if you train your data on only cars that aren't red, you're going to run into a problem when the red car comes up, because it might have one model that says red cars are bad drivers, or one model that says red cars are good drivers. And at that point, it's going to weigh the data and create a bias. So you need to divide up all those different features. This comes out extremely heavily in doing population statistics, where we might pull an area out, run the statistics, but because we're basing our statistics just on that area and the people that live in there, that area might be predominantly one group of people. And then you have a minority that is part of that group, but there's a bias as far as how they fit into the data and how it weighs their particular choices. And then you start running into problems with the bias on there. That's why using stratified k-fold cross-validation is a very important thing to add into your toolkit when you start looking at the different data structures and validating your models. Stratified k-folds overcomes this by maintaining the same percentage of data classes in all the folds. Models can be trained even on minority classes. And you can see here where even though we have 5 separate splits in the data, we used k equals 5, each one has a representation of all the different features in there, so that we help get rid of that bias and help each one train equally across the data.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So with that, let's roll up our sleeves. We're going to do a demo where we use adult census data to predict whether a person is making above $500,000 a year. I'm going to go out on a limb and guess that that is not U.S. money, because that's $500,000 in the U.S. But it's still good money. Then we use cross-validation on our model to see which one is performing better. Who is earning less than $500K? That is the question we're going to ask here. For our demo, we're going to be using Python 3, which you can use in whatever IDE you want. I myself am going to be using Anaconda Notebook, which opens up a nice web page. And from here, we'll just go ahead and create ourselves a new data set, or a new Python scripting page. And we'll start by bringing in our different modules in here. And you'll see in here, let me go ahead and change this to, red's fine. No, we'll go with black. We'll see up here at the top, we have our pandas and NumPy. This is your NumPy array and your pandas data frame, which we always like to use because they look so nice and easy to use and view. And of course down here, here's our data frame here, where we're going to load up our data and take a look at it in just a minute. And then from our sklearn module, which you can see on the next set of lines here, we have our logistic regression model, k-neighbors classifier, and then our cross-val score, stratified fold, k-fold, train test split, and k-fold. And so this is really what we're looking at right here. We're looking at how to validate our different models. And it looks like we're going to be doing this in logistic regression and k-neighbors classifier, so we can have something to compare on there. And then, of course, once we have done this, we need to go ahead and have some data. So we'll go ahead and run this. Here's our data set. And this is actually, let's see, we're using pandas, so this is a data frame. And then the first thing we're going to look to see if we have any null values. Always check your data and see what you have coming in. You just never know. And so we can see here with our quick dataset.is null and summit that we have 0 null values in our data set. So we've read our data set in, and the first step in any data is always to take a look at it. So we'll take our data set and we'll go ahead and do .head. Now remember, in Jupyter Notebook, if this was not the only line or the last line of my code on this particular grouping of cells, I'd have to add print around it. Otherwise, it just automatically prints it for us. And we can see here, here's our actual data. And so we have, of course, a nice, the titles up here, age, work class, different information, education, I guess what level of education, marital status, relationship, not in family, race, sex, capital gain, capital loss. And if you remember correctly, I talked a little bit about social minorities. Imagine if you were someplace where the predominant area is all in India, someplace where everybody's Indian, and there's a small group of people who are what they call expatriates, who came from America and happen to be white. Well, you're going to run into a problem when we did that cross-validation, because if we're looking at this, we might notice that, or in this case, just looking at the first four things, we see three people who are white, one person who's black. This might be a huge discrepancy in our data, and we want to make sure we split that out or take a look at that. We probably won't get into that too much today, but just be aware that this is the kind of thing that you want to start flagging yourself on. And it might be, here we have work class, private. I'm not sure what that means. There's a lot of question marks here. That's kind of important to note also. And these are just some of the things I start to look at when I look at this data on here. Native country, United States. So these are people coming from the United States. And here's our 50,000. Now remember, we're looking for 500,000. So the average person here is probably around 50,000. Maybe we'll take a look at that and see what kind of spread we have on our data. But it's a good place to start. And we'll go ahead and do this as a print head 10. The reason I wanted to do that is so we can take just a little closer look at some of the data we're looking at. And if we go up here, let's put a drawing on there. Let's take a note here under sex. We're talking about that. Probably convert that to 0 and 1. And we're going to drop a lot of these columns on here. Maybe we'll also just look at marital status. We might want to convert this to 0 and 1 on here. Some other things that we're not looking at is, of course, race. And this kind of gets interesting because when you look at race, they only show, right now, I only show the two variations. We'd look at how many variations there are. Same thing with male and female. If we label one of these 0 and 1, 1 is not greater than 0. And 0 is not greater than 1. What that means is that this is a yes-no, but as we get more variety, you can't do that. You can't do a yes-no. You have to start splitting that up into multiple columns. And again, it depends on your data and what you find out. You might come in here, like we have marital status. We'll actually look a little deeper at marital status. A couple different options in here. One is just to convert this to married or not married. That's a 0, 1. We might split this into columns where widow would be 0, 1, divorce would be 0, 1, separated 0, 1, and so forth. Again, it depends on what kind of data we're looking at and how deep we want to get into it. So let's go ahead and clean up our data a little bit here. Let's start by cleaning up a few columns. And again, we're going to drop a bunch of these because we don't want to spend too much time cooking our data and getting it all set up correctly. We want to have a little bit more time to focus on cross-validation. And you'll see here on this, we have here I was talking about the sex. We're going to convert that to male 0, female 1. And then we'll do the same thing with marriage status. At this point, we're going to create married status. Widow is going to, if you're never married, divorced, separated, widow, it's going to be 0 for single. And then we're going to put this as 1 if you're married. And let's go ahead and convert this into a typed integer. So this works really nicely. We'll have 0 and 1 for single or married, and then there's going to be an integer. That way our different models can recognize it. Most models don't recognize text unless you encode it somehow. Just real quick before we start looping through the different models, we got to remember to create our Y, which is going to be our income. That's our answer. And then, of course, from the data set, drop the Y, because we don't want to use it as part of the processing. And the other thing we want to look at, this is the code for creating our X-train, Y-train, X-test, Y-test. So normally, a lot of times you'll see this where we just split the data and we think, okay, good, I've got my test side, I got my Y side, but we're going to go ahead and create a loop so that we can go through this and then take a look at that as far as coming up with the results on there with a cross-validation score. So let's go ahead and run this. Shoop. And whoops, I must have mistyped something. all I need to do is rerun the threads because I'd run it twice, and so it didn't like changing things up when I'd already run it once, and I've already made too many changes on here. So we go ahead and run this, and now we have an X train and a Y train. We're not actually going to do anything with this X train and Y train here. This is just a reminder for what that looks like. But we do need our data set and our Y part of the data set on here. So the next step, and this is the kind of thing I love working with, is we create our models. And you can see where you can start creating really robust packages to compare different models. Again, remember, we're dealing with small data. If you did this across big data, you can run into some major problems. And so we're going to import the two different data models, logistic regression and k-neighbors classifier. And we go ahead and pin these both to models on here. And if we do something like print models, we'll go ahead and run that. You can see that we have a title, which is a string, and then a function, and we can run each of these functions going through our different setup. And then what we really want to do is we want to create a loop for the different models and go through the cross-validation score on the different models. And we'll go ahead and do, I'm going to create a results dictionary. One of my favorite things to do is put everything in dictionaries. And we're going to go for name and model in models. So for each row we have the name LR and then the model is a logistic regression model. And then we'll go ahead and do our k-fold. Right here, this k-fold is the heart of the setup on this. I think the random state is being changed because it threw a warning on there and how that's being done. We'll take a look at that in just a second, the warning. And then we have our splits. We're doing 10 splits on here with our k-fold. And then we have our results. And once we have our results, which is going to be we're going to have a row of 10 pieces of data from each different fold. And so we want to go ahead and do the mean on that. Oops, there we go. Go the arrow the wrong way. And the standard deviation. So how much do they deviate from each other? How low is our error on here? The lower the better. So let's go ahead and run that. And then of course I have on mine, there we go. We see down here is our future warning. It says something about random states. I'm not going to worry too much about that. Warnings come up so often when you're running these different configurations because they're always making changes on here. And so I've got in here my results. Here's my results with the name, and it's going to be the means and the standard deviation on here. Oops, there we go. That way. There's our means and standard deviation. And then I always like to do key value just because this reminds me very much of doing mapping in larger data. You usually have a key value for your setup. And we'll print the key value, which in this case is the name of the model and the results on here. And we can see down here, here's the two models we ran. Clearly I could add like a ton of these different models long as they are part of the Simplilearn setup and they use the same input. There are some models that work slightly differently, so you don't want to use if you're doing classification and then you switch to regression, you run into problems. And of course we're doing regression here, and we can see our results. The KNN did slightly better. It had lower errors, and look at the standard deviation. The standard deviation is also lower. So if I was running this model, I would go for, I'd be looking at the KNN as my primary model. I would then go rerun this model on all the data to send out for future predictions of stuff we don't know. And you can see right here, it does a nice job. It 0.77 versus 0.79, and we'd pick this. You could run this across, like I said, a lot of times there's like about 6-7 different models in there. Some of the models have different settings, so you might go in there and mess with the settings. There's all kinds of ways to go through this. And then you can take your, in this case, cross-validation with, in this case, when we had 10 folds, and you can get a good idea of what kind of setup or which model is going to work the best, and then compare it, and then you go back through your feedback loop of how to build it and send it out. And of course, from this model, you have somebody new come in, and you find out what their marriage status is, their education, this different information that we put in here. You might find out what their predicted income is. Yeah, it worked pretty good. I definitely wouldn't make it the primary goal with a 0.79 over here error on there, or with this kind of setup on the means, but it would give you a good idea what you're looking at for people coming in if that's what you're trying to evaluate. So that wraps up our demo. In this case, we're specifically looking at our K-folds. We didn't get into looking at the different columns and how to split it, but we did get into going through different models and doing a basic K-fold split on them and how that works. Thank you for joining us today at Simplilearn. For more information, please visit www.simplilearn.com.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.